All right. How's it going, everybody? I know that things have been a little bit crazy and uncertain for the last few days, but I think starting to get a handle on stuff and things are starting to settle down. Um, Hopefully, you are feeling the same way. We're still a little bit up in the air about what your education is going to look like over the course of the next 5 or 6 weeks, whatever it is now. Um, but I thought I would go ahead and just start throwing some stuff out there for you guys to take a look at if you want to. This is not an assignment. This is not something that will affect your grade or is required for the class. It's just a way for you to, I don't know, keep learning, keep current. Some of you might be a little worried that you're going to get behind, for SATs or college or, whatever. So at this point, this is just if you want to. That might change in the future. If that does, then I will let you know. Anyway, so where we left off, I don't know if you remember back in those crazy days when we were all together, was figuring out how to do the exact sine and cosine of different angles in both radians and degrees. What we're going to chit chat about today is how to do the same thing with the other trigonometric functions. And so what I'm going to do is I'm going to go through some notes here. I apologize in advance for my absolutely horrible writing using the mouse on my computer because I'm at my home, not at school. And then I will put some problems at the end for you to do if you're interested in trying them to see if you understand what I was yickety-yakking about. And then when I'm done with this, I'll make another video of me going through the answers to all of the exercises for you to do, like I said, if you want to check and see if you know what you're doing, okay? All right, so the other four trigonometric functions are the tangent function, which is defined as the y-coordinate of the point on the unit circle divided by the x-coordinate. The secant function, which is defined as the radius of the circle divided by the x-coordinate. The cosecant function, which is the radius divided by the y-coordinate, and the cotangent function, which instead of being y over x, is x over y. So good news, the process we're going to go through today is pretty much the same as what we were doing last week in class. We are going to start with an angle. We're going to use that angle to draw a reference triangle. We're going to use our special right triangles, 30, 60, 90, and 45, 45, 90, to figure out the coordinates of the point. And then the only thing that's different is instead of just going x over r for cosine and y over r for sine, we're going to set up some different ratios to figure out these other functions. All right, so let's get crack-a-lacking on that. So let's figure out what, first of all, the tangent of 45 degrees is. So this is a relatively simple one because it's in the first quadrant, but we can go ahead and draw our reference triangle anyway. So 45-degree angle will be something like this. And then if I do as my teacher told me and draw my reference triangle always to the x-axis, then I will have myself a good old-fashioned 45, 45, 90. Okay, so then if I go and look at my special right triangles, that tells me what the different sides of that triangle would be. So this is 1, and this is 1, and this is the square root of 2. So that means that the coordinates of this point, if I go to the right to get there, would be 1, and then I would have to go up 1, so the coordinates of that point is 1, 1. Now I have all the information that I need. I have the x, I have the y, and I have the r. So I'm going to go back and look at the definition of tangent that I just gave you. That is y over x. And so in this case, the tangent of 45 degrees would be y over x, which is 1 over 1, which is 1. Okay? Look, my handwriting's going to get better. Just trust me, it's going to be all right. Okay, then to figure out the secant of 5 pi over 6, our first job is to change 5 pi over 6 into degrees, because nobody knows what 5 pi over 6 really means. So I'm going to do that by multiplying by 180 over pi. So the pi's cancel. 180 divided by 6 is 30, and 30 divided by, or 30 times 5 is 150. So what we're really talking about is a 150 degree angle. So let's get my reference triangle going here for that. So 150 degrees means 0, 90, and 60 more. So that means that the angles in this reference triangle will be, this was 150, so that means I have 30 left for this little piece right there. That, boys and girls, is in fact a 3. There we go. This one's going to be 60. And then, of course, this is the old 90 degreeer. So if I go back here and look at the 30, 60, 90, I can find the lengths of the 3 sides based on that. So that tells me that this side is 1. This side is 2, and remember, since we're going to the left, we're in quadrant 2, this side right here is negative square root of 3, okay? So that means that this point is negative root 3, comma, 1, and my radius is 2. X is negative square root of 3, y is 1, radius is 2. And so now if I look at this, to find the secant, that is r divided by x. So that tells me that the secant of 5 pi over 6 is r, which is 2, divided by x, which is negative square root of 3. And that's it. There you have it. And that is really all we are looking at doing in this section. Let's do one more together, just for funnies. So let's do a cosecant one. So I'm going 7 pi over 6 into degrees. So I have to multiply by 180 over pi. Pi's cancel. 180 divided by 6 is 30, and 30 times 7 is 210. So that gives us the reference angle, because if I start at 0 and go 90, 180, and then another 30 to 210, then that tells me that this angle is going to be 30 degrees, which means this angle is 60 degrees, because I am going to draw the triangle straight up from there. Alright, so I got myself a 30, 60, 90 triangle, so I go back to the special triangles and I look and see what the 3 sides of that are. The one across from the 30 is 1, but since we're in the 3rd quadrant, that's actually going to be a negative 1. The one across from the 60 is the square root of 3, but again, since we're in the 3rd quadrant, that's going to be a negative 3, and the hypotenuse here is 2. So the coordinates of this point right there, which is what we're worried about, are x coordinate of negative square root of 3, and the y coordinate of negative 1. Okay? So how do we turn that into the answer to the question that we were asked? Well, the cosecant of 7 pi over 6, cosecant is, cosecant is r over y. So we know that the radius is 2. hypotenuse of the triangle is always the radius, and the y-coordinate of this point is -1. So the cosecant of 7 pi over 6 therefore will be -2. Okay? Alright, that's all we need to accomplish today. We're just easing our way into this. We'll see how this all goes. So like I said, if you want to try some problems to see if you're understanding what I'm doing, then here are some that I would suggest that you do. I will go ahead and post this video to Google Classroom and then make a video of me going through these problems, and then we'll just take it from there. If you guys have questions, if you have comments, if you have suggestions, just comment on Google Classroom or send me an email, and we'll get it figured out. Okay? All right. See you later.